Now, a steam drum is again the integral part of a steam generation unit or a steam distribution system under the edges of chemical process utilities. Now, before we go into the detail of the steam drums, just to have a recap towards the topics which we covered previously. So, previously we covered the topic pertaining to the superheaters, steam temperature control systems. We discussed about the various types of reheaters, and we discussed about the concept of a leakage in air heaters. Now, in this particular lecture, we are going to cover the attemperators, concept of steam drums. Then we will discuss about the various parts of steam drums. Let us start with the attemperators. Now, the boiler attemperators, they are used to fine tune or control the steam temperature from a boiler as well as the steam temperature between the boiler stages. Sometimes different type of a boiler stages being used. So, they are used to control their steam temperature. Now, what are the desirables in the attemperators? One is that they must be able to control the temperature during startup, shutdown. Sometimes turbine may get tripped, and sometimes turbine runs on a full load, and also provide the precise temperature at all conditions while withstanding with the high temperature difference and the cycling. Now, these attemperators, this includes the high pressure interstage, reheat interstage and final stage. If you recall that we discussed the various kind of reheaters in the previous lecture. Now, the attemperators, they are located in steam pipe work upstream to the steam turbine. Now, see here, this is the steam pipe work, and you are having this attemperator. So, they allow very fine control of final steam temperature by spraying the precise amount of water into the steam flow. So, again this is the usual way to control the steam temperature. Now, the steam temperature from the boiler is normally controlled slightly above the final temperature required. This is attributed to the various irreversibilities associated with the steam piping network. And this the steam temperature is then attemperated downward, as it is easier and more effective and precise to control the final temperature with attemperation than with the boiler control. So, by this way one can maximize the efficiency, because sometimes if you are producing the steam at the desired temperature and a pressure at the boiler end, and if it goes to the point of use, then sometimes you may not have the steam with a proper temperature or a pressure. So, in that case a slightly above temperature, the production of steam at a slightly above temperature always be desirable. But in that case sometimes you need to go for the precise control of the temperature. In that case the attemperators are very useful device. So, an attemperator spray reduces the steam temperature in the superheaters zone of a boiler, so as to maintain around say 535 to 540 degrees centigrade temperature at the inlet of the steam turbine. Similarly, it is also used as the exhaust to lower the steam entry temperature to the condenser. So, by this way you can maximize the efficiency of the condenser. Now, here you see that the process flow diagram. Now, here you see that the condenser is returned to the feed water tank. Now, here this you can see that this is the feed water tank. Now, this feed water is pumped to the boiler house, you see, using the boiler feed water pump, this boiler feed water pump. Now, a minimum feed water flow valve is also mounted in the line to optimize the flow rate, that is quite obvious. And the feed water is first passed through the preheater economizer section. Here you see that this goes to here this is the preheater and this is the economizer section or system. Now the saturated steam produced is then separated from the water. Here this is the drum and it is separated from the water in the steam drum. As we discussed that this serves as the steam separation unit, and it is having the steam chest as well as the water chest. Now this separated water is then transferred to the drum outlet tank for recycling. Now the saturated steam collected from the steam drum is then superheated to a slightly higher temperature in a primary superheater. So you see that there are two superheaters, 1 and 2. The superheated steam temperature is controlled through the attemperator situated between the primary and the secondary superheater using a spray of water. So you are supplying the spray water through this spray water controlled valve. The controlled temperature superheated steam is finally superheated up to the desired temperature and pressure for the use in a high pressure turbine. The condensed low pressure steam, this can again heated using the reheater. Here you see that this is the reheater, followed by the temperature control using the secondary attemperator situated between the heaters. The produced intermediate or low pressure steam is then used in intermediate or low pressure turbines. Now there are several problems associated with the temperatures. One is that undesired water addition due to improper temperature operation or through the leakage from the control element. And second is that it sometimes result to the damage of hardware and piping due to the thermal shock. It can also lead to the erosion in the piping network. Another problem is associated with the temperature is that in case of interstage temperatures, sometimes they show inability to provide final steam temperature in the desirable range. So your entire purpose may not be fulfilled. This can be caused due to the inappropriate turn down, due to unregulated changes in the spray water flow, or due to the leakage within the control system. Sometimes such failure can reduce the steam cycle efficiency and output of electricity. Poor design, installation and a faulty control system, these can also be the root causes of these problems.